log base a of m equal n, and that's how it's read, log base a of m equals n, if and only if a to the nth power is m. So, in other words, when it asks you for the log of something, they're asking you for the exponent. They're asking you for the power. So let's look at some examples. Log base 2 of 32 is 5 because 2 to the 5th power is 32. Log base 3 of 81 is 4 because 3 to the 4th power is 81. Log base 5 of 25 is 2 because 5 to the 2nd power is 25. Log of 1000, which is the same as log base 10 of 1000, equals 3 because 10 to the 3rd power is 1000. Log base 4 of 64 is 3 because 4 to the 3rd power equals 64. The statement where it says log base 4 of 64 equals 3, this is the logarithmic form of the statement. Whereas 4 to the 3rd power is 64 is the exponential form of that statement. So as you can see, statements can be written in two forms, and they're really inverses of each other. So now let's look at some more examples. Log base 2 of 8. Well, we know that 2 to the 3rd power equals 8. Therefore, log base 2 of 8 is 3. Log base 3 of 27. We know 3 to the 3rd power is 27. Therefore, log base 3 of 27 is 3. Log base 5 of 625. 5 to the 4th power is 625. Therefore, log base 5 of 625 is 4. Log base 7 of 1. Any number except for 0 raised to the 0th power is 1. Therefore, log base 7 of 1 is 0. Log base 2 of 1 over 64. Now we have a fraction. It's under 1. That means your exponent is going to be negative. So since 2 to the 6th power is 64, 2 to the negative 6th power is 1 over 64. Therefore, log base 2 of 1 over 64 is negative 6. Log of 100,000, or log base 10 of 100,000. 10 to the 5th power is 100,000. Therefore, log of 100,000 is 5. So as you can see, if we have a log without a base, that means it's base 10. 10 is the base. But I want to introduce to you another special form of logarithm. And that's called the natural log, which is abbreviated ln. The natural log of m means log base e of m, where e has a fixed value of 2.7182818, and etc. So if you see natural log of m, that's what it means. It means log base e of m. Now, I want to introduce to you the change of base property, which is also called the calculator property. On the previous examples, we know what certain powers are, but let's say we don't know what certain powers are. Well, the change of base property, or the calculator property, says this: log base a of m equal log of m over log of a. This is what you put into your calculator. And your calculator will tell you what it is. That's why it's called the calculator property. So let's look at some examples of this. Log base 7 of 12,567. All right, so we're trying to find out log of 12,567 divided by log of 7. We put this in the calculator, and you will get 4.851. They want you to round it to the nearest thousandth, which is 3 decimal places. Next, we have log base 5 of 2100. So we're going to write it as log of 2100 over log of 5. Put it in the calculator. And you would get 4.753. Next, we have log base 11 of 5,176. So this is log of 5,176 divided by log of 11. So we're going to put this in the calculator. And you would get 3.566. Next, we have log base 4 of 200. So this is log of 200 over log of 4. Put this in the calculator. Hold on for a second. Let me do this again. You would get 3.822. Next, we have log base 6 of 17,497. So this is what we're putting in our calculator. Log of 17,497 over log of 6. So we're going to put this in our calculator. And you would get 5.453. So finally, we have log base 9 of 1,287,999. So this is log of 1,287,999 over log of 9. Enter it into a calculator. And you would get 6.403. And therefore, this is our solution. So when they ask you for a log of something, they're asking you for a power. And if you're not sure what that power is, you can use the change of base property or the calculator property to find out what it is. It is all straightforward. I hope that you have a wonderful and blessed day.